So again, my name is Jim Elliot. I run the memory marketing organization for Samsung in Semiconductor in San Jose, California, and wanted to give you a brief overview on what we're doing on the memory side. And the title of my presentation is SSD and DDR3, which is really Semiconductor's best power play, as we like to call it. So the first question I want to start out with is, why is green important? There's a couple reasons. Number one, from a financial or from a government standpoint, it's extremely important. It's about $78 billion from the stimulus package is earmarked for clean energy and tech. VC companies invested more than $4 billion in green startups in clean energy in last year alone. Regulators, NGOs, and the media, of course, all very big stakeholders in this. And there's a sense that the companies, if they're not innovating by themselves, that innovation is going to happen for them or that legislation is going to be mandated. So it's better to get out in front of the curve. And lastly, retailers and consumers. You look at Best Buy and Walmart. The CEO of Best Buy says 5 out of 5 for the importance of industry going green, and Walmart has actually introduced a supplier scorecard based on greener purchasing attributes. So if we look at Semiconductor's role in this green enabling, you can sort of see where we are down at the bottom of this food chain. We're like the plankton or that single cell amoeba at the bottom of this. And as we get more and more complex, we feed into these electronics, into these other areas or systems, into the service providers, gaming, broadcast, telecom up at the top. So everything we do at the semiconductor side is going to influence everything much further downstream as we go. So the key point here is the products must perform. Green in and of itself cannot supersede. So from a products or from a features and performance standpoint, these are the most important attributes. Environmental consciousness and pricing is going to come after the product benefits. From a cost perspective, very similar to what Dr. Steele talked about, some customers are willing to pay about 10 to 20% higher. Interestingly enough, in Seattle, consumers are willing to pay about 30% higher. So this does differ by geography. And lastly is total cost of ownership. This break-even point must be attained quickly, if not immediately. And the best example I can give here is after the economic crisis hit at the end of the fourth quarter last year, the CFL light bulb sales took a nosedive for the first time ever. So again, you have to have that instantaneous break-even in a lot of examples. So where's Mr. Lucas, our PR gentleman? We put out a press release today talking about the dynamic duo of memory and our role in greening electronics. And that dynamic duo is really DRAM, DDR3, and NAND with SSD. On the DRAM side, we are scaling down to 1.35 volts. It's going to give us more than a 50% reduction in power. We'll go into why that's significant here in a moment. And on the NAND, or SSD, which is a solid-state drive, it's a semiconductor-based hard drive. That's up to 40 minutes more before charging in a notebook. In the notebook space and in the enterprise or the server space, you're going to get orders of magnitude improvement over the performance characteristics of a hard drive. So if we look at the disruptive value that the two of these offer together, an SSD, you're going to get about a 50x improvement over a 15K RPM hard drive. More than 80% power reduction. So you net those two together and it's about 200 times more efficient. So again, extremely compelling. You can replace multiple hard drives with one SSD in a server or enterprise. In fact, we've heard that number be as high as 30 to 1. Less real estate and lower cooling costs. DDR3 side, higher efficiency per watt. It's about double the fast or double the speed of DDR2. We're going from, again, a 1.8 down to a 1.5 and a 1.35 volt device. More than 50% power savings and, again, lower cooling costs. We do expect DDR3 to cross over DDR2 by the end of 2009. So let's focus on SSD here for a moment. Again, you're going to save about 80% from a power consumption standpoint versus HDD. Virtually no heat emissions, because again, remember, there are no moving parts. This is silicon-based. And there's a compounding effect here because there's no fans needed to cool the products. On the DRAM side, again, as we go from DDR2, 1.8 volt, to DDR3, we move to 1.5 volt, and we can continue to scale that down to 1.35 volt. Net at the higher densities, we can achieve almost an 80 or a little above 80% power reduction for the same amount of memory footprint as we move down this lithography continuum from 80 nanometer to 60 nanometer into the 4X technology in the future. And again, this thing becomes extremely compelling when we look at the server space where the gigabytes or the amount of DRAM in a server continues to increase. So the bigger the footprint for the memory, the more power savings you're going to achieve by converting everything from DDR2 over to DDR3. So along those lines, we have released a 32 gigabyte DDR3 registered DIMM targeted for the server markets, enterprise market, higher density, better performance, lower power, and a smaller or same footprint, which allows you to have a greater amount of memory density and performance and throughput for the same amount of real estate. So the net is you're going to get much more efficiency using these types of products. So let's look at case number one on the client side in the notebook space. In 2007, we were doing some research. About 160 million computer products were disposed of, and about 80% of those ended up in landfills. And one of the challenges we have here is the lithium-ion battery recycling challenge. It's not very economically viable. You need, for about 1,000 pounds, or 2,000 pounds rather, a ton of these batteries. The recycle value is only about $100. So it's very, very difficult to have any intrinsic economic value behind that. So where's Mr. Yang from iSupply? There he is right over there. Came out with a very interesting report recently, I think just last week, that showed that if we convert from an HDD to an SSD in a notebook, we can actually, because of that power savings, about 80% less, we can go from a 6-cell battery in a notebook to a 4-cell battery in a notebook utilizing this. So if we take this data and extrapolate it out in the number of SSDs that are going to be sold into the notebook space, taking those all from a 6-cell down to a 4-cell configuration, again, the SSD is going to offset that. You can save about 334 million battery cells over a 5-year period. So again, very, very compelling value proposition there from an economic or from an environmental standpoint. So let's look at case number two in the enterprise space. Again, this is an area that is certainly ripe for what we call disruption. Data centers, as you can see on the chart on the upper left, emit more CO2 than the country of Argentina. So again, this gives you a sense of the scale or the magnitude of the challenge that we're thinking about. And if you look at data centers, they're rapidly approaching airlines in terms of the amount of carbon dioxide emissions. One point I want to mention, and I know our CE guys love to hear this, which is that Americans consume more power with their data centers than they do running all of its televisions. And in fact, current EPA estimates show that at its current trajectory, data centers could represent about 3% of U.S. energy consumption by 2011. So let's take a practical look at some of what our customers are doing here to utilize some of this new DDR3 technology. So what's happening here is HP, for example, is saving energy, reducing their footprint, and gaining on what they call their TCO, or total cost of ownership. If you think about it, there's about 12 million servers out there that are more than 4 years old. So this is the perfect replacement cycle to hit with some of this DDR3 technology. So for example, if you look at an HP G4 system from just a few years ago versus a new ProLiant G6 system, you can replace 9 of the old with 1 of the new, and you get the same throughput from a resource standpoint, same workload. So 9 older servers, that's 61% power reduction, 40,000 kilowatt hours per year, at about 10,000 annual OpEx savings by utilizing this new server technology based on DDR3 components. The SSD, again, very disruptive in the enterprise space, both from an IOPS per dollar as well as an IOPS per watt perspective. IOPS per dollar, you get about a 12x increase relative to an HDD. But again, if you extrapolate this based on the IOPS per watt, IOPS is, again, just throughput or calculations, more than 200x. So again, this is that orders of magnitude improvement that the SSD is going to bring into the enterprise space. If we look at how this market is going to proliferate here over the next couple of years, you can see millions of units. This year, 2009, it's about a 1 million unit market. 2013, going to about 7 million units. Total of about $2.2 billion worth of SSD into the enterprise and industrial markets. What's interesting here, though, is if you look at the disparity in 2013, 7% of SSD units, but 33% of SSD revenue. That disparity really showcases that value proposition that SSD brings into the enterprise.